The battery monitoring system consists of a master node and several slave nodes, with one node dedicated to each cell within the module. These nodes communicate with each other via infrared components in a daisy chain topology. The master is placed opposite the slave to simulate power-up. At this point, the slave node wakes up, and its red indicator LED starts to blink. The CEA cell holder, which houses the slave card, has holes that serve as light guides for infrared communication. On the oscilloscope, the slave's response frames appear when power is applied. Then, the master's requests and the slave's responses are repeated periodically. A clock signal is continuously sent from the master node to the slave node to ensure real-time management of the information circulating on the bus. This allows for the synchronization of the voltage measurement of each cell with the current measurement taken on the master side. The initial signal is the UART frame transmitted by the master node to the first slave node. It contains a request for information, such as the cell voltage or temperature. The frame is divided into a clock signal and a data signal. The transmission of the signal can therefore be achieved using a single infrared diode, with the principle of amplitude modulation being employed. The signal received by the slave node therefore comprises two levels, one for the clock signal and one for the data signal. These different levels are detected by comparators, and the UART frame can be decoded by the slave. In response to a request from the master, the slave will measure and report its cell voltage or temperature. The frame is sent by another infrared diode, this time without using modulation. At the end, the master node decodes the frame and is then able to use it. The desired number of slave nodes is added to the daisy chain. In this step, 10 slave nodes are embedded in the heads of CEA custom cell holders. We can use the camera to observe the violet infrared signal traveling from the master node to the slave nodes and back again. The oscilloscope displays the signals exchanged between the nodes in the form of data frames. The master node initially transmits a frame to the first slave requesting cell voltage measurements. The first slave then responds by transmitting the request to the second slave. The second slave then does the same, responding to the request and transmitting it to the third slave. Each response from each slave is relayed by all previous slaves up to the master node. The last slave in the chain detects when it has not received a response and terminates the process. The master therefore receives the voltages from each slave in turn. This process is repeated to obtain the temperatures. All the data is sent from the master node to a computer via a CAN bus. The interface displays all cell voltages and temperatures, updating every 100 milliseconds.